So I'm going to take this matrix here, and I need to multiply that by something, and I need to get back the identity matrix. So I said I didn't want to deal with subscripts, so I'm not going to deal with subscripts. Instead, I'm going to call this one, so here's my matrix A, and this is what I'm trying to find, and that's my matrix A inverse. And I'm going to give it capital letters, A, B, C, D. Okay. I'm not going to do this whole thing out, but on the left-hand side, I do need to do this matrix multiplication. So I've got a 2 by 2 times a 2 by 2, and a 2 by 2 times a 2 by 2. I know that I can do that multiplication. They're the same dimension, and my result will be a 2 by 2 matrix. So I'm kind of going to hit fast forward on the multiplication here. So I'm going to have, see how I do. This is row 1, column 1. So I've got row 1 times column 1. So I'll have A. I'm going to try to write left-handed. Plus B, C. Okay, doing okay with the left-handed. This is row 1, column 2. So I need row 1 times column 2. So I'd have A, B, plus B, D. I'm in row 2, column 1. So row 2, column 1. I'm looking at C, A, plus D, C. And then over here, that's row 2, column 2. So row 2, column 2, C, B, plus D, D. And that has to work out to be equal to the identity matrix. And this is the point where I said I'm not going to finish this all the way out. But essentially, we have 4 unknowns because we're trying to solve for the A, B, C, and D in this inverse matrix. And I can break this up to be 4 equations. So I'd have this has to be equal to 1, this has to be equal to 0, this has to be equal to 0, and this has to be equal to 1. That's 4 equations and 4 unknowns. And a whole boatload of algebra later, you'd get an answer. Now I'm just going to jump to what that answer looks like. If I have a matrix, A, B, C, D, and specifically for a 2 by 2 matrix, then A inverse is equal to, and I'm going to write this as 1 over the determinant of A, just we'll come back to what that determinant is. And then I'm going to put this matrix here. So we have to compute the 1 over the determinant part, and then what goes in here, the way I remember it is we flip the diagonal, and we make the off diagonal negative. Now, if we were to actually work out all of this algebra up here, we would find out that this determinant here, that determinant of A is equal to AD minus BC. So I'm going to erase all of this